Well, here we are on lesson 21, section 7.6, and we're going to be dealing with the inverse trigonometric functions, and the key term there is functions. So here's a little bit of a review. In the range 0 to 2 pi, find the values of the variables that make the equations true. So we look at the tangent of theta is equal to 1 over square root of 3, and we think of what angles have a tangent of 1 over square root of 3, and we come up with two answers, and the same for sine and the same for cosine. And for tangent theta equal 1 over square root of 3, there are two angles between 0 and 2 pi that make that a true statement, pi over 6 and 7 pi over 6. For sine beta equals square root of 3 over 2, there are two angle betas that make that a true statement between 0 and 2 pi, pi over 3 and 2 pi over 3. Sine is positive quadrants 1 and 2. Anyway, wrap it up. Cosine alpha equals 1 over square root of 2. Cosine is positive in quadrants 1 and 4, so that'd be pi over 4 and 7 pi over 4. So these three are just reminders of what we've done in the past, and we're going to build on that in the rest of the lesson. So now we're going to define inverse trigonometric functions. And you're going to remember that term, what the word function means. And you've defined that many times in the past. So do you remember how to define if a graph of an equation is a function? You remember what you had to do? Remember that test? Remember, it has to pass the vertical line test. So if you graph the function and you pass a vertical line, as you pass a vertical line from left to right, the graph can only intersect the vertical line one time at one place, and in order for it to be a function, or in other words, for every x there is one and only one y. So when we give you an equation, there can only be one answer for that question or that equation. And that is the definition of a function. For every x, there is one and only one y. So today we're going to be defining the inverse trig functions, inverse sine, inverse cosine, inverse tangent. And your calculator will be a large help here, because your calculator only returns values in certain quadrants when working with inverse functions. So this is going to be a help for you to determine the ranges for inverse, sine, cosine, and tangent. Because again, we're going to call these functions. So every time we do the inverse, sine, cosine, or tangent of something, of a value, there can be one and only one answer. And I want to make sure you understand that your calculators will be a big help to you. So every time we find the inverse sine, or rather the arc sine of a value, it is always defined between negative pi over 2 and pi over 2 inclusive. In other words, those endpoints are inclusive. And your calculator only returns values between that range, negative pi over 2 and pi over 2, or rather negative 90 degrees and 90 degrees, whenever you hit inverse or arc sine. Arc tangents also defined between negative pi over 2 and pi over 2. Now notice it's non-inclusive, those are parentheses at the end, or negative 90 degrees and 90 degrees. So every time you hit inverse or arc tangent, you only get values between negative pi over 2 and pi over 2. And inverse cosine or arc cosine is defined between 0 and pi. Every time you hit the inverse cosine key, it always returns an angle between 0 and pi. So these are the ranges for the inverse functions that we'll be talking about today. And this is reinforced each time you use the inverse tangent, inverse cosine, or inverse sine keys on your calculator. And again, I'm going to keep stressing this, that inverse tangent and arc tangent, inverse cosine, arc cosine, and inverse sine, and arc sine are exactly the same thing. And to stress that, here we go. Arc sine is the same as inverse sine, and it always returns an angle. Arc cosine is the same as inverse cosine, and it always returns an angle. And arc tangent is the same as inverse tangent, and it always returns an angle. Inverse sine, inverse cosine, inverse tangent return angles. We feed them fractions or ratios. That's the x values. And after we come out of there, what falls out of the function is an angle. All right, so let's do a series of these. What is the inverse sine of negative 1/2? Now, inverse sine is only defined between negative pi over 2 and pi over 2. There is one and only one answer to this question. What is the angle whose sine is negative 1/2? Well, sine is negative down there in quadrant 4. Quadrant 3 is out of play, so let's not talk about that. So what is the angle down there? Whose sine is negative 1/2. And you might be tempted to say 11 pi over 6, but 11 pi over 6 is out of range for inverse sine. You had to give me an answer between negative pi over 2 and pi over 2. And the answer was negative pi over 6. That's the angle between negative pi over 2 and pi over 2 that makes this a true statement. There can be one and only one answer. All right, how about inverse cosine square root of 2 over 2? What angle has a cosine of square root of 2 over 2 between 0 and pi? Because inverse cosine is only defined between 0 and pi. Well, hopefully you said pi over 4. Normally we don't have too much trouble with the inverse functions when there's a positive argument like this, pi square root of 2 over a positive square root of 2 over 2. So it was an acute angle, and it was pi over 4 because the cosine of pi over 4 is square root of 2 over 2. But there is one and only one answer because it's only defined between 0 and pi. How about inverse tangent of negative 1? Well, let's see now. An inverse tangent is only defined between negative pi over 2 and pi over 2. You should be thinking about a 45-degree angle. And you might be tempted to say 7 pi over 4, but 7 pi over 4 is way out of range. Inverse tangent is only defined between negative 90 degrees and positive 90 degrees, or negative pi over 2 to pi over 2. So the answer is negative pi over 4. There is one and only one answer. All right, arc sine. Remember, that's the same as inverse sine. Arc sine of 1/2. You ought to be thinking in the range of negative pi over 2 to pi over 2. And the angle in quadrant 1, who has a sine of 1/2, is pi over 6. Arc sine, inverse sine is only defined between negative pi over 2 and pi over 2. And again, normally when there's a positive argument, in this case positive 1/2, students normally get these right because these are the acute angles there in quadrant 1. All right, arc cosine or inverse cosine of negative square root of 3 over 2. That has to be over in quadrant 2 because inverse cosine is defined between 0 and pi. This is a negative argument, so we need to be in quadrant 2. And so that's the 30-degree angle over in quadrant 2. It's 5 pi over 6. Notice inverse cosine or arc cosine always returns a positive angle. Yeah, because it's defined between 0 and pi. Unlike inverse sine, inverse tangent, which can return negative angles when you feed it a negative argument. All right, inverse tangent, or rather arc tangent of square root of 3. I think we need to find an angle in quadrant 1. And the inverse, or rather arc tangent of square root of 3 is pi over 3. We had to find an angle in quadrant 1. It was a 60-degree angle up there, so pi over 3 is our answer. So there has been one and only one answer to every one of these questions. Why? Because inverse sine, inverse cosine, inverse tangent are functions, and there can be only one answer. All right, what about this one, though? What is the sine of the inverse sine of square root of 2 over 2? So arc sine, arc cosine, arc tangent returns an angle. Sine, cosine, and tangent returns a ratio or a fraction. So in this case, as we're looking for the angle, we're looking for the sine of the angle whose sine is square root of 2 over 2. So first work inside out, we'll work from right to left. The arc sine of square root of 2 over 2 is pi over 4. So that's the angle that gets returned when you do the inverse sine of square root of 2 over 2. Now the question is, what is the sine of pi over 4? And the sine of pi over 4 is square root of 2 over 2. So this shouldn't have been a big surprise. I mean, think about the original question. What's the sine of the angle whose sine is square root of 2 over 2? Well, it's square root of 2 over 2. All right, what's the cosine of the inverse cosine of 1? So in other words, it's saying, what's the cosine of the angle whose cosine is 1? And so the inverse cosine of 1 is 0 because the cosine of 0 is 1. So the inverse cosine of 1 is 0. Now we're asking, what's the cosine of 0, which I think I just answered. And the answer is 1. And it shouldn't be a big surprise. The original question was, what's the cosine of the angle whose cosine is 1? It's 1. And so this one says, what's the tangent of the angle whose tangent is 5? And you know, I have no idea what the tangent of 5 is. I'd have to pull my calculator out. And in fact, in all these examples that I just completed, this being the third one, you could use your calculator. You could put 5 in, hit inverse tangent, and then hit tangent. And if you did that, you'd get 5, right? Because again, it's saying, what's the tangent of the angle whose tangent is 5? It's kind of like asking, what's the color of the vehicle whose color is green? And so this is really the same thing. And again, the reason 5 shows up is, well, 5 is in the range of tangent. It's okay. So here's a recap here of the 3 previous problems we've done. And so notice that the sine, arcsine, cosine, inverse, cosine, tangent, inverse, tangent cancel out, and you get square root of 2 over 2, 1, and 5 for your answers. Now the reason they do, though, the reason square root of 2 over 2, for instance, works in the first one is because it's in range of sine. And the reason 1 works is because it's in the range of cosine. And the reason 5 works is because it's in the range of tangent. Now, in the next few examples, we're going to reverse this. Put the arc function on the outside and put the function on the inside. And you have to remember, where does arc sine, arc cosine, arc tangent return values? You can only give me answers in those ranges. So what is the arc sine of the sine of 5 pi over 4? And you'd be tempted to say 5 pi over 4, thinking those functions cancel each other out. But arc sine's on the outside here, and arc sine only returns angles between negative pi over 2 and pi over 2. 5 pi over 4 cannot be the answer. It's out of range. So the sine of 5 pi over 4 is negative square root of 2 over 2. So listen, we're just going to work this thing from right to left. So first we identify the sine of 5 pi over 4, which I stated here is negative square root of 2 over 2. What is the inverse sine of negative square root of 2 over 2? It's negative pi over 4, because inverse sine only returns values between negative pi over 2 and pi over 2. And since we fed it a negative argument, negative square root of 2 over 2, it returned a negative acute angle, negative pi over 4. All right, arc cosine of 5 pi over 4. People are tempted to answer 5 pi over 4. They want the functions to cancel out, but it doesn't happen in this case because 5 pi over 4 is out of range. Inverse cosine, arc cosine can only return values between 0 and pi. 5 pi over 4 is out of range. All right, well, the cosine of 5 pi over 4 is, again, negative square root of 2 over 2. And what is the arc cosine of negative square root of 2 over 2? Well, that would be 3 pi over 4, because the cosine of 3 pi over 4 is negative square root of 2 over 2. 3 pi over 4 is in range. The answer had to be between 0 and pi. 5 pi over 4 was out of range. And the last of the 3 trick questions, what's the arc tangent of the tangent of 5 pi over 4? And again, 5 pi over 4 is out of range of inverse tangent, so 5 pi over 4 can't be the answer. The tangent of 5 pi over 4 is 1. The arc tangent of 1 is, think about it, pi over 4. Pi over 4 is in range of inverse tangent, rather 5 pi over 4 is not. The inverse tangent of the arc tangent of 1 is pi over 4. So here's a quick review. Notice that none of the answers were 5 pi over 4, because 5 pi over 4 was out of range for all 3 of these functions: arc sine, arc cosine, arc tangent, inverse sine, inverse cosine, inverse tangent. You have to give an answer that's in range for the function. And if you have to work inside out, then that's what you do.
So we'll wrap up this lecture with 3 examples of where there are no shortcuts. You just have to simply work from right to left. And here we go. We want the sine of the angle whose cosine is negative square root of 3 over 2. Our answer is going to be a ratio. Inverse cosine returns an angle. The sine of an angle is a ratio or a fraction. So we want the sine of the angle we want the sine of inverse cosine of negative square root of 3 over 2. We want the sine of the angle whose cosine is negative square root of 3 over 2. So there's no shortcut. We're just going to work from right to left, inside out, however you want to say it. The inverse cosine of negative square root of 3 over 2 is 5 pi over 6. Inverse cosine is only definable between 0 and pi. We had a negative argument, negative square root of 3 over 2, which means we need an obtuse angle, quadrant 2 angle, and it's 5 pi over 6. So now we simply need the sine of 5 pi over 6, and we're done. The sine of 5 pi over 6 is a half. So again, we were asking for the sine of the angle whose cosine is negative square root of 3 over 2, and it meant we were finding the sine of 5 pi over 6, and the sine of 5 pi over 6 is a half. Let's do another one. We want the cosine of the inverse tangent of 1 over square root of 3. Again, we want the cosine of the angle whose tangent is 1 over square root of 3. And working from inside out, the inverse tangent of 1 over square root of 3 is pi over 6. Again, tangent is inverse tangent is only defined from negative pi over 2 to pi over 2. We gave it a positive argument, so we had to come up with a quadrant 1 angle, and the inverse tangent of 1 over square root of 3 is pi over 6. Now we have to find the cosine of pi over 6. And the cosine of pi over 6 is square root of 3 over 2. From start to finish, we wanted the cosine of the angle whose tangent is 1 over square root of 3. That meant we want the cosine of pi over 6, and the cosine of pi over 6 is square root of 3 over 2. Let's move on to our last problem. So we want the tangent of the angle whose sine is negative 1/2. Tangent of inverse sine of negative 1/2. And again, working from right to left or inside out, the inverse sine of negative 1/2 returns negative pi over 6. Inverse sine is only defined between negative pi over 2 and pi over 2. So I want the tangent of negative pi over 6. And the tangent of negative pi over 6 is negative 1 over square root of 3. It could have been negative square root of 3 over 3. I kind of like negative 1 over square root of 3 for my answer on that one. We wanted the tangent of the angle whose sine was negative 1/2, and that answer is negative 1 over square root of 3. That wraps it up. Well, this concludes lesson 21. Get to work on the homework.